Welcome to the MGC channel and our program Operating Room Wall Protection Solutions, presented by MGC Incorporated, Houston, Texas. Visit us online at www.mgcinc.net. Our objective in this program are to discuss the performance guidelines for healthcare finishes, to identify common operating room wall finishes, to compare the performance of each type of operating room wall finish, and finally to understand the design options available for the surgery suite utilizing solid surface wall protection. Operating room wall finish performance guidelines. No national performance specification exists for finishes. Instead, there are guidelines and research from a variety of organizations, such as the Center for Healthcare Design, the Robert Wood Johnson Foundation, Healthcare Without Harm, and the Coalition for Health Environments Research. In terms of references available, there is the 2006 Guidelines for Design and Construction of Healthcare Facilities. Since 1947, the Guidelines for Design and Construction of Healthcare Facilities has set minimum standards for American healthcare facility design. Today, these performance-oriented requirements give healthcare providers and design professionals guidance on good practice and emerging trends. The Joint Council on Accreditation of Healthcare Organizations and federal agencies and authorities in 42 states use the guidelines either as a code or a reference standard when reviewing, approving and financing plans, licensing, certifying or accrediting completed facilities, or in developing their own codes. Often called the AIA Guidelines, the guidelines provide a number of recommendations for preferred finishes and surfaces. This is an excerpt from the guidelines, the appendix, which shows 18 preferred surface characteristics for finishes and surfaces in a healthcare facility. Now let's discuss the modern types of operating room wall finishes. Painted gypsum, ceramic tile, UPVC, PETG in the .040 thickness, PETG 3/8 inch, often called high impact PETG, epoxy resin, stainless steel, and solid surface. We want to discuss the 8 modern types of operating room wall finishes in depth with their advantages and their disadvantages. Let's begin with painted plasterboard or painted gypsum. Most operating room walls are painted plasterboard or a combination of painted plasterboard and another type of wall protection. The requirements for painting the walls of a hospital operating room are that the coating must either be a semi-gloss or a full gloss coating. The higher the gloss, the harder the paint. Typically, epoxy and polyurethane coatings are used because they do withstand light washing with hot water or water containing mild detergents. Painted plasterboard offers the lowest initial investment of all of the identified modern wall protection systems. Painted plasterboard, however, compromises sterility. The wall material is porous, it has a high dielectric constant, it gathers and holds dust and infectious organisms. Paint cannot withstand repeated high friction scrubbing, so operating rooms are rarely scrubbed, and therefore even when the hospital reaches its highest level of cleanliness, bacteria still resides on the walls. Painted plasterboard, while the most common of all the modern operating room wall finishes, is one of the poorest choices of materials if you're following the key performance criteria of wall finishes in the guidelines for design and construction of healthcare facilities. Ceramic tile. Surgical suites in the 1950s and 1960s were designed for the function and the technology of that era. Most operating room walls had ceramic tile walls as the upgrade alternative to painted plasterboard. Ceramic tile offered increased impact resistance and comparably a much improved level of infection control. The use of ceramic tile in surgical suites during that era resulted in a shorter cleanup time and ultimately in an improved turnaround and the ability to provide more procedures. When surface humidity exceeds 80%, which is common in most operating rooms, ceramic tiles can harbor mold and mildew, and it's difficult to prevent their growth. Unfortunately, the maintenance of grout joints is often overlooked until irreversible damage to the walls has occurred and serious concerns arise. Walls with ceramic tiles are not recommended in surgery suites because the joints are difficult to clean, non-resistant to wear, and not durable. UPVC, or unplasticized polyvinyl chloride. In 1969, a PVC wall protection system was introduced that was capable of being manufactured in virtually any shape. Facilities designers everywhere fell in love with the product's extreme durability, so it quickly became the wall protection standard. UPVC is also known as rigid PVC, is extensively used in the building industry as a low-maintenance material. UPVC is known as having strong resistance against chemicals and oxidation from water. UPVC is a hygienic wall system that is heat welded and thermoformed to inside and outside corners. The seamless design allows for an ultra-hygienic wall surface. Seamless wall systems are ideal solutions for wall protection and hygiene in operating rooms. UPVC is described as having no phthalates or BPA and erroneously advertised as being safe because of this description. Vinyl chloride is classified as a human carcinogen by the United States Environmental Protection Agency and can be off-gassed in conditions of humidity and heat. All vinyl plastics have volatile organic compounds in them. VOCs are released as vapors, which when inhaled or absorbed through the skin can cause a number of health problems: irritation of the eyes, nose, and throat, blurred vision, dizziness, joint pain, fatigue, nausea, pain in the chest, and palpitations or skipped heartbeats. The more serious ones, damage to the kidneys and lungs and liver, infertility, and cancer, particularly that of the testicles, are very likely when exposed to a significant amount for a long period of time. Now let's go with PETG 0.040 thickness. Responding to requests from specifiers and end users no longer wanting PVC in their facilities, PETG wall protection sheets were developed. PETG is a clear amorphous thermoplastic in the polyester family that can be injection molded or sheet extruded. When considering application in operating room wall protection, PETG shows great promise in the quest for alternatives to PVC. PETG sheets can be jointed with mastics, trims, or welded to form a moisture-resistant wall finish. PETG has a significant flaw, however. While more durable than many plastics, it can be extremely brittle. This leads to a problem in the operating room: poor impact resistance. One of the key performance criteria of operating room wall protection is to often absorb impact from carts and equipment. PETG in its pure form cannot take hard abuse. It cracks and breaks. PETG panels installed utilizing the color match trim creates voids between the trim and the panels that can trap moisture and promote the growth of harmful bacteria and molds. PETG 3/8 inch or high impact PETG. In an effort to resolve the moderate impact resistance of PETG, many manufacturers offer a 3/8 inch panel. This panel is actually the 0.040 PETG sheet that's bonded to a medium density fiberboard core. The impact resistance of the panel is significantly increased with this process. However, the physical properties of the PETG remains unchanged, and the presence of the wood-based core limits the joining techniques, and it introduces an entirely new set of precautions if the PETG is compromised. Epoxy resin. Epoxy terrazzo is a highly decorative, pigmented, 100% solids, two-component epoxy resin system. It's mixed with a wide variety of aggregates and trowel applied to a nominal thickness of 1/4 inch to 3/8 inch. Epoxy terrazzo provides outstanding durability. It does not support bacterial growth and is available in conductive and novolic formulations. Epoxy terrazzo offers maximum stain resistance from iodine-based disinfectants. Integral floor and wall detailing provide crash cart resistant impact walls. However, epoxy terrazzo requires a moisture barrier and requires expansion control joints to prevent cracking the product. Epoxy terrazzo is not considered sustainable and it's not easily repaired. Epoxy terrazzo wall protection has a high initial investment, which results in an unprofitable relation of cost to effect. Epoxy terrazzo also limits the possibilities of adding new system elements. Stainless steel. Stainless steel is a ferrous alloy containing a minimum of 10.5% chromium. The use of other alloy elements such as nickel, molybdenum, copper, titanium, as well as nonmetals, especially carbon and nitrogen, result in longer structure and improvements in other qualities such as durability. Stainless steel is known for its resistance to corrosion. Corrosion resistance of stainless steel is connected with its chromium-rich oxide layer, which forms naturally on its surface. This protective layer is adjacent and chemically stable, as well as self-renewable as long as it's got an appropriate amount of oxygen that's provided to the surface. Thanks to its chemical parameters, stainless steel is extremely hard and smooth. These qualities prevent the development of bacterial colonies on its surface. This material is also resistant to disinfectants and cleaners used in hospitals, which guarantees long-lasting use of stainless steel products. Stainless steel wall protection does have a high initial investment, which results in an unprofitable relation of cost to effect. Stainless steel wall panels, when properly installed, have no horizontal seams to promote the growth of bacteria and mold. However, the vertical seams are unavoidable with a stainless steel wall system. The properties of stainless steel prevent sound absorption and contribute to glare unless powder coated, which impedes the inherent properties of the chemical parameters of the product as well as adding cost to the initial investment. Stainless steel wall panels limit the possibilities of adding new system elements. Now let's talk about solid surface. Solid surface is a combination of natural and synthetic ingredients. The first major ingredient is a mineral, the filler. The other is a resin, the binder. Also included are various additives for color and performance enhancements. These are combined and cast into shapes or sheets. Alumina trihydrate, or ATH, has great physical properties and serves as the filler for most solid surface products. It's refined from bauxite ore, which is a form of clay. It's hard enough to give superb impact resistance, but soft enough to be machinable. And one last almost magical property. Not only will it not burn, but because it has water and hydration, when attacked by heat, ATH actually releases steam, which makes it a natural fire retardant. The two main families of resins used to make solid surface are acrylic and polyester. A purely acrylic-based resin yields a sheet that is thermoformable. That is, it can be heated, bent into a shape, and cooled without any loss of performance. Solid surface has no fissures, and it's not porous, so it doesn't require any sealing. Because of its chemical composition, it doesn't support the growth of mold or mildew. It is seamless because the two-part adhesive used for joints basically becomes solid surface when it dries. It is therefore also repairable. It is easily renewable with the proper equipment, and it can easily be sanitized with a bleach product to get rid of germs seen on its surface. These characteristics make it a superb product for use in surgery suites. Now let's review the performance comparisons between the 8 different products that we've identified. You can see the key performance criteria listed on the top of the chart and the product type on the side of the chart. When you look at it, the 1/4 inch solid surface is the only product that meets all the key performance criteria identified in the guidelines for design and construction of healthcare facilities. The ease in maintenance or repair, the sustainability of solid surface. Solid surface material can be patched, repaired, creating a seamless patch. If you move monitors and items attached to the wall, you can cut out the damaged solid surface material and seam a new patch in its place. Simple standard templates are available, and all fabrication shops are capable of accomplishing this standard task. In the first photo, you see where a template was set and a piece of solid surface cut out. The second picture shows the adhesive that's used. Another piece is put in its place. Then it is sanded and buffed out, and it looks like a brand new sheet. Solid surface does not support microbial growth. It's smooth and it's seamless. A hospital-acquired infection, also known as HAI or as a nosocomial infection, is an infection whose development is favored by a hospital environment, such as one acquired by a patient during a hospital visit or one developing among hospital staff. Such infections include fungal and bacterial infections and are aggravated by the reduced resistance of individual patients. In the United States, the Centers for Disease Control estimate roughly 1.7 million hospital-associated infections from all types of microorganisms, including bacteria, combined to cause or contribute to 99,000 deaths each year. Solid surface is an optimal material to use as an infection control strategy. It is non-porous, it inhibits microbial growth, and seamless, limiting where the bacteria can become trapped. A typical application in a hospital operating room is the thermoform corners. The fabrication in the second picture shows how it's an overlapping seam that's a seamless fabrication with the adhesive. And if you seal the transitions between the flooring and the solid surface, there's no place for bacteria to hide and grow. Let's talk about the sound absorption qualities of solid surface. The outstanding acoustic properties of solid surface have led to its use in design and manufacture of audio instruments and equipment. Solid surface has comparable acoustic properties to medium density fiberboard. Flammability, fire rating, and smoke toxicity. The United States of America has a federal structure. However, building codes and regulations are the responsibility of the individual states through local regulations. Many building authorities utilize the National Fire Protection Association's NFPA 101 Code for Safety to Life from Fire in Buildings and Structures for fire regulation guidance. Generally, local authorities favor codes developed by organizations within their region of the United States. Building codes may or may not be adopted in their entirety by the local community. As you can see, solid surface carries the highest interior ratings finish, Class 1 or Class A, of the principal USA building codes. Durable, resilient, impact resistant. An example is the IZOD impact test or the ball impact test. As far as durability, LG Hymax, for example, has passed extensive impact tests, making the material ideal for high use areas. Low VOCs, off-gassing, non-toxic, and non-allergenic. All major manufacturers of acrylic solid surface products have been third-party tested for compliance with VOC restrictions and restrictions of hazardous substances, including the low VOC material certified through GreenGuard, Air Quality Certified, third-party certified to comply with the European Directive 2002 on the restrictions of hazardous substances, and third-party certified to comply with South Coast Air Quality Management District Rule number 1168. Acrylic solid surface does not off-gas, is non-toxic, and non-allergenic. That makes it the premier product for use in healthcare facilities. Now let's talk about the initial investment and the life cycle cost effectiveness. This chart illustrates the low cumulative investment of acrylic solid surfaces, the red line. compared to the other surfaces in the blue line. The initial investment of acrylic solid surface is moderately priced on the scale of the identified wall protection surfaces for operating room walls. You have to keep in mind that the initial investment of the other surfaces on the right is heavily skewed by extremely low initial investment of painted plasterboard and even the 040 PTEG. The potential reduction in the cost of hospital-acquired infections has to be factored into the life cycle cost effectiveness of solid surface. According to the CDC, nearly 2 million patients annually contract an infection while being treated for another illness or injury. In the United States, there are around 99,000 deaths each year due to hospital-acquired infections. Additional research indicates that hospital-acquired infections are costing hospitals across the United States over $3 billion annually. In conclusion, acrylic solid surface is the optimal product for surgery suite wall protection. It is the only material discussed that meets all the key performance criteria identified in the guidelines for design and construction of healthcare facilities. Let's look back at our objectives. We've identified the performance guidelines for healthcare finishes. We've identified the common operating room wall finishes. The performance of each type operating room wall finish was compared to each other. And we've discussed the design options available for the surgery suite utilizing solid surface wall protection. If you have any questions or for more information, contact your MGC regional manager or call 713-800-7300. I hope you enjoyed the program.